Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about marginal density functions of x and y example. And this is the previous examination question. The example is the joint probability density function of two random variables capital X and capital Y is given by f of x comma y is equal b e power minus 2x cos of y by 2 for x is equal to 0 to 1 and y is equal to 0 to pi and f of x comma y is equal to 0 elsewhere. Find the value of b, and second bit is marginal density functions of x and y. Coming to the solution, given that the joint density function is f of x comma y is b e power minus 2x cos of y by 2 for x is equal to 0 to 1 and y is equal to 0 to pi. First calculate the value of the b. So first check it the given joint density function is valid density function or not. If f of x comma y is the joint probability density function, then integral minus infinity to infinity, integral minus infinity to infinity, fxy of x comma y dx dy is equal to 1. And the joint density function is always non-negative, that is fxy of x comma y is greater than or equal to 0. If this condition is satisfied, hence the given joint density function is a valid joint density function. And after that, using this expression, calculate b value. So first check it fxy of x comma y is greater than or equal to 0 or not. So from the given data, the range of the x is equal to 0 to 1 and y is equal to 0 to pi, and the minimum value of x and y is 0 comma 0 and maximum value of x and y is 1 comma pi. So first substitute 0 comma 0. The given density function is fxy of x comma y is b e power minus 2x cos of y by 2. At 0 comma 0, that is minimum value of x and y, f of 0 comma 0 is b e power minus 0 into cos 0. E power minus 0 is 1, cos 0 value is 1. So f of 0 comma 0 is b. So b is a positive quantity. So that is therefore f of x comma y or fxy of x comma y is greater than or equal to 0. And for maximum values of x and y, from the given that the maximum value of x and y is 1 comma pi. So in the given joint density function, substitute x is equal to 1, y is equal to pi, we get f of 1 comma pi is b e power minus 2 into cos of pi by 2. Cos of pi by 2 value is 0, 0 into something 0, f of 1 comma pi is 0. So therefore, from the above two conditions, in this case, fxy of x comma y is greater than or equal to 0. So this condition is satisfied. Hence, the given joint density function is a valid joint probability density function. And after that, using this expression, we can determine b value. So now, integral minus infinity to infinity, integral minus infinity to infinity, fxy of x comma y dx dy. So now here the range of the y is 0 to pi from the given data, and the range of the x is 0 to 1, and the joint density function is b e power minus 2x cos of y by 2 dx dy is equal to 1. So first integrating with respect to x, integral e power minus 2x dx is e power minus 2x by minus 2 over 0 to 1, and substitute upper value of x and lower value of x, we have minus b by 2 integral 0 to pi cos of y by 2. Substitute upper value of x and lower value of x, e power minus 2 minus e power minus 0. E power minus 0 value is 1. So that is equal b into 1 minus e power minus 2 by 2 integral 0 to pi cos of y by 2 dy is equal to 1. So now integrating cos y by 2, cos y by 2 dy is integral cos y by 2 dy is sin y by 2 by 1 by 2 over 0 to pi. So now substitute upper value of y and lower value of y, we get b into 1 minus e power minus 2. Now here 1 by 2 is the cancel. cancel. B into 1 minus e power minus 2 into sine of pi by 2 minus sine 0. Sine of pi by 2 is 1, sine 0 is 0, 1 minus 0 is 1. So therefore B is equal to 1 by 1 minus e power minus 2. So e power minus 2 is written as 1 by e square, and after that take the LCM. We have B is equal e square by e square minus 1. This is the constant B. And the second bit, determine marginal density functions of x and marginal density function of y. So we know that the basic expression of the marginal density function of random variable x is fx of x is equal integral minus infinity to infinity fxy of x comma y dy. Now we are applying the given data. Given that the joint density function is b e power minus 2x cos y by 2, and the range of the integral from the given data y is equal to 0 to pi. So now we are integrating with respect to y. B e power minus 2x is constant, that is written before integration, and the b value is already calculated, and substitute that b value into here. e square into e power minus 2x by e square minus 1 integral 0 to pi cos of y by 2 dy. Integral cos of y by 2 dy is sin of y by 2 by 1 by 2, and now substitute upper value of y and lower value of y. We get fx of x is equal e square into e power minus 2x by e square minus 1 sin pi by 2 minus sin 0. Sin pi by 2 is 1, sin 0 is 0. So 1 minus 0, 1. So therefore fx of x is equal to, now we are 1 by 1 by 2 is 2. So 2 e square e power minus 2x by e square minus 1. So e square into e power minus 2 is written as e power 2 minus 2x. 2 into e power 2 minus 2x. So now here 1 by 2 is there, that is coming to the numerator here 2. 2 into 2 into e power 2 minus 2x by e square minus 1. So this is the marginal density function of random variable x. So next calculate the marginal density function of random variable y. The marginal density function of random variable y expression is integral minus infinity to infinity fxy of x comma y dx. Now applying the given data, the joint density function is b e power minus 2x cos y by 2 dx, and given that the range of the x is 0 to 1. Now here integrating with respect to x, b cos y by 2 is constant, that is written before integration. B value is already calculated, substitute that b value into here. Fy of y is equal e square by e square minus 1 into cos of y by 2 integral 0 to 1 e power minus 2x dx. Integral e power minus 2x dx is e power minus 2x by minus 2, and now substitute upper value of x and lower value of x. We get fy of y is equal e square by e square minus 1 into cos of y by 2 e power minus 2 minus e power minus 0. E power minus 0 is 1 by minus 2. So now where the denominator minus is there, multiplying numerator term with minus, we get 1 minus e power minus 2 by 2. So this e power minus 2 is written as 1 by e square. So take the LCM. Here e square minus 1 by 2 e square. So numerator and denominator e square is cancelled. E square minus 1 is cancelled. Therefore, the marginal density function of random variable y is fy of y is equal 1 by 2 cos of y by 2.